The area and perimeter of a rhombus. Okay, so a rhombus is like a square that is laid on its side. And when we talk about a rhombus, we have to remember that all those sides are always going to be the same length, and the area of a rhombus, the formula for that is 1/2 d1 times d2. Well, when it talks about d1, it's talking about your diagonals across. So that's like d1. Then we're going to have a diagonal across the other way, and that would be your d2. So then perimeter is, again, of course, just the sides all added up together. So we're going to do a few examples, and I don't know why this turned out the way it did, but these numbers are supposed to be down here, so I'm going to fill them in. All right, that's what we're given. And we're supposed to find all the indicated measurements. Okay, so diagonal 1 can be this one. So we see that it's 3 from here to here, and then 3 from here to here. So we add that together, that makes 6. The diagonal 2 is our other diagonal, which we see is 4 plus 4, so that is 8. So area, we're going to use our formula, 1/2 the diagonal 1 times the diagonal 2. Well, that's going to be 1/2 times 6 times 8. Well, if you multiply all that together, you're going to get 24. So the area is 24. Now we've got to find the side length. So what's important to remember here is that when you create these diagonals in a rhombus, then it always creates this 90-degree angle. And so if you notice then, if we've got a 90-degree angle, we really just have a triangle that we have created up here. So let me draw out this triangle. And here's our 90-degree angle. So we know that the hypotenuse is always across from that. So we can use our Pythagorean theory to figure out the hypotenuse, or one of these lengths that we're not given. So we can say 3 squared plus 4 squared is equal to c squared. So remember that c is always the hypotenuse, which is directly across from the 90-degree angle. Well, 3 squared is 9 plus 4 squared is 16, and that's equal to c squared. Add those together, we get 25 is equal to c squared, and we want to know what c is, so we take the square root of both sides, so c is 5. So our side length is 5. So we can say this is 5, then this one's 5, this one's 5, and now this one's 5. Well, for a perimeter, we add up all the sides, which is 5 plus 5 plus 5 plus 5, or 4 times 5, which is 20. So our perimeter is 20. All right, the next one, we're told that we have a rhombus that has diagonals of 10 and 20. So let's just draw out a rhombus here. And that's not very good, but so we're told one diagonal is 10. We're told the other diagonal is 20. And we're just going to find the area and the side length of all these. So area, again, using our formula, 1/2 diagonal 1 times diagonal 2 gives us 1/2 10 times 20, and that is 100. So the area is 100. So our side length, and then we're going to look for perimeter. Okay, so side length, notice if we have those, the rhombus, and if we're told one diagonal is 10, it's got to be 5 and 5. So the 21 has got to be 10 and 10. Remember, this is the one that creates the 90-degree angle. So we've got this triangle, right triangle created here, so we can use Pythagorean theorem to figure up that side length. So that's 5 squared plus 10 squared is equal to c squared. So 25 plus 100 is c squared. 125 is c squared. Take the square root of both of those. And I think if you look in your calculator and do that, you're going to get like a decimal, 11.18. But let's rationalize that so that we have an exact figure. So that tells us that c is the square root of 125. The square root of 125 is 25 times 5. The square root of 25 is 5. And we're still left with that square root of 25. So the side length is 5 square roots of 5. Now the perimeter, or all those sides added together, which we can also, if you just notice, that's also 4 times whatever that side length is, 5 square roots of 5, which makes that 20 square roots of 5. Okay, for our next one, we were told this is 25, 25, 25, 25, and this was 24. I'm going to go ahead and mark this other one. We were told this is 30 and this is 60, and that's all we are told there. Okay, so we are going to find all of these lengths again. So D1, D2, we're going to find the area, we're going to find our side length, and then we're going to find the perimeter. So we've got a lot to do on this one. Okay, so notice, let's just go first. This length is 24. Well, then we should automatically know this side is also 24. So that diagonal has to be 24 plus 24, which is 48. All right, our diagonal 2, we don't know what that is. So that's one we're going to have to use the Pythagorean theory. But notice we're given our hypotenuse, which is the 25. So we're looking for one of those side lengths. So that is going to be 24 squared plus that x squared is equal to 25 squared. Remember that one on the outside, your c is always your hypotenuse. Okay, so x squared is 25 squared minus 24 squared, which gives us 49, and the square root of that, so x is 7. So notice this is 7, and that just tells us that one triangle, so we know this side is also 7. So that second diagonal is a total of 14. So now let's go find the area. Now that we know our two side lengths, we're going to say 1/2 diagonal 1, which is 48, times diagonal 2, which is 14. And if we get all that together, multiply all that, it is 336. So our side lengths are 25. We're given that. So then our perimeter, or all those side lengths added together, or 4 times 25, which is 100. Okay, on this one, we are told that we have a 60-degree angle inside here and that we have one side length that's 3. So let's just start filling in other information that we automatically would know. So this has to be 3 also. Now we can use our formulas for a 60-degree triangle, 30 degrees on the other side. remember that that is x square root of 3. The 60 degrees is the x, and the hypotenuse is 2x. Well, in this instance, if that x is 3, then we know this side length is going to be 3 square roots of 3. And then the hypotenuse, which is 2 times x, or 2 times 3, is going to be 6. So then we can fill out the rest of this information. We know all those side lengths have to be 6. And we know the other section of that diagonal has to be 3 square roots of 3. All right, so now let's go fill out all of our information. Diagonal 1 is going to be the 3 plus 3, so that's 6. Our second diagonal is going to be 3 square roots of 3 plus 3 square roots of 3, which gives us 6 square roots of 3. The area is 1/2 diagonal 1, which is 6, times diagonal 2, which is 6 square roots of 3. Well, let's break this down. 1/2 times 6 is 3. And then we're going to say times 6 square roots of 3. Remember, you can only multiply whole numbers times whole numbers, not that root. So 3 times 6 is 18 square roots of 3. So your area is 18 square roots of 3. Then our perimeter, we know our outside edges are all 6. So 4 times 6, which is 24. So the perimeter is 24. Okay, last one. We have a rhombus that has an area of 44 centimeters. Okay, so remember, here's our formula. Area is 1/2 diagonal 1 times the diagonal 2. Well, we know what the area is. We know that is 44. One diagonal is 11. We're looking for the other diagonal. Okay, so let's just break this down, and I don't know why these numbers are all here, but let's just pretend like they're not. So 44 is equal to 1/2 times 11. So 44 is equal to 1/2 of 11, or 0.5 times 11 gives you 5.5, then times our diagonal 2. So we're just going to divide both sides by that 5.5. We're going to get our diagonal 2 then is 8. So diagonal 2 is 8. And I think that's all it asks us for. I don't know why all this is over here. So